started putting out these forecasts back in 1995 for the April forecast. This is the 41st year that we've done seasonal forecasts in general. A couple of indices I want to draw your attention to. Accumulated cyclone energy. That's kind of a key metric accounting for storm frequency, intensity, and duration. We actually use that as a primary forecast metric. So all of our models actually forecast ACE, and then we derive the other parameters from that one ACE. Of course, you can have ACEs that are very similar, but very different numbers of storms. For example, we have 2004, 2005 ACE, which is about 10% of each other. 2004, 15 storms in general. 2005, 28. Because ACE is frequency, intensity, and duration, long-track hurricanes like Ivan in 2004, Irma in 2017, Dorian in 2019 generate huge levels of ACE. New index that we started forecasting last year, ACE west of 60 degrees west, also terms ENS ACE. This is ACE in the western half of the basin, so this is when we'll find a lot of planes into the storms. That's where all the people live in the Atlantic Basin. So when you have a lot of wind energy generated in the western half of the basin, that's not great. An ACE relative to basin-wide ACE this year is somewhat higher than last year because we're expecting to transition over to La Nina conditions, and I'll talk more about that in a couple of minutes. When it comes to seasonal forecasting, I had to dig up this old cartoon, try to kind of change the message here to start. So this is Dr. Bill Gray, the founder of the seasonal forecast. We're giving him an award awaiting his memory this evening. This is not how our forecasts are done. You might think, hey, this is Dr. Gray looking at the crystal ball, saying, verily, I see 17 mean storms. It's not how we do these seasonal forecasts. What we do is we use historical weather and climate information to come up with these hurricane predictions. Dr. Gray was teaching tropical meteorology in the early 1980s, and this is long before we had Wikipedia. We had back in the day we had Encyclopedia Britannica and all that great stuff. Dr. Gray knew which years were active hurricane seasons, and he knew which years were El Nino years. And he said, when we have El Nino years, we tend to get fewer hurricanes in the Atlantic Ocean. That's interesting. Why would something going on in the tropical Pacific impact hurricanes in the Atlantic? And so we know El Nino is warmer than normal water in the central and eastern tropical Pacific. La Nina is colder than normal water in that same region. If we look at the schematic on the left, when you have that warmer water in the eastern and central tropical Pacific, your strong thunderstorms tend to like to form over the warmest water. So in El Nino, those thunderstorms tend to shift somewhat farther to the east. And so when you have thunderstorms, you have low winds converging into those thunderstorms. The air goes up in the thunderstorms, you get really pretty cumulonimbus clouds at upper levels, the winds diverge. So you increase your upper level westerly winds in El Nino years relative to La Nina years. However, your low level winds in the tropical Atlantic blow out of the east. These are the trade winds. They pretty much always blow out of the east. At upper levels, they tend to blow out of the west. So within El Nino, you have a lot stronger westerly winds, much more vertical wind shear. Too much vertical wind shear is detrimental to hurricanes, tends to help tilt the hurricane circulation, disrupt it, and you get fewer hurricanes and weaker storms in general. So El Nino tends to knock down your storms, La Nina tends to really increase your storms. But it's important to take into account a lot more than just the El Nino-La Nina phenomenon. As we saw last year, we had a busy hurricane season, well below normal shear, with the strong El Nino because the Atlantic was so damn high. And also kind of some of the structural, the sea surface temperature anomaly pattern that we had across the tropical Pacific last year also was another factor. How good are these forecasts? And so one thing I do emphasize is, unfortunately, in general, the April forecast gets the most media attention. I wish it were the later forecast because this is kind of like putting your most focus on the 10-day weather forecast as opposed to the forecast for today. The skill of the forecast doesn't improve as we get closer to the events we're trying to predict. So you can see to the left is April, then we go to June, we go to August, the columns get higher. But one thing I also want to draw your attention to is the red column is higher than the blue column, meaning we're getting better, which is good. And there's a couple of reasons for that. One, the historical data that we base our models off of is better than it used to be. It's kind of funny to think, how can history be better? But we now have better models that can basically take these local observations that we did have and give us a more accurate because in general, the proverbial wisdom was if you have a strong El Nino, it dominates over everything else. But the climate models last year said we're going to have a strong El Nino, the Atlantic is going to be very warm, and we're going to see low shear in the Atlantic, and that actually played out quite well. So that kind of gave us increased confidence, and I think we would have had, say, 20 to 30 years ago where we didn't have still full climate models. So here's what we're currently looking at. So there's still a lot of red mold, so the world is quite warm. But really one of the things that we even started thinking about last year was, okay, the Atlantic's record warm, assuming the strong El Nino dissipates, which they normally do, how is that going to play out in 2024? If we have a continued warm Atlantic, but without the El Nino putting somewhat the brakes on, especially in the western part of the basin, we didn't see much storm activity in the Caribbean last year. So right now we still have that El Nino, but it really is truly sticky. There's not much warm water beneath the ocean surface, and that's more a harbinger of what we're looking to see in the next few couple of months is a quick transition into neutral and possibly La Nina conditions. We can see the Atlantic is also still extremely warm. The anomalies have come down just slightly, but we're still well above the long-term average and still at record warm levels for the latter part of March across most of the tropical Atlantic. So we're going to talk about two regions in the next few minutes. The first, that blue rectangle denotes the Nino 3.4 region. That's the region that NOAA uses to monitor the state of El Nino and La Nina. That's what happens when scientists name stuff. We come up with exciting names like the Nino 3.4 region. In the Atlantic, we have the Atlantic's main developing region, which is so named because that's where the hurricanes and development and intensify in the Atlantic. And so you see that obviously again running at very, very warm levels right now. So here's what we have again in the tropical Pacific. We still have that El Nino right now. It's borderline weak to moderate in that box. It's about 1 degree Celsius-ish warmer than normal. But if you look at the subsurface, the waters beneath the ocean surface, this is going down 300 meters or about 1,000 feet. The waters are quite cold. And so typically what goes on the subsurface is a good predictor for what you're going to see at the ocean surface. And I'm sure we all love our Homer plots. So on the top of this plot is basically now, and on the bottom of the plot is the middle of May. And this is averaged over 5 degrees south or 5 degrees north, so generally right along the equator. And so in this plot, blues indicate easterly winds out of the east, reds indicate winds out of the west. And if you look across the tropical Pacific, you see a lot of blue, indicating we're getting stronger trade winds blowing across the tropical Pacific. That tends to basically enhance upwelling, bringing that colder water to the surface. So I suspect we're going to see those warm waters in the tropical Pacific likely dissipate here and potentially have a quick transition over to La Nina, which matches up quite well with what NOAA and National Oceanic and Atmospheric Administration is seeing. Greater than 80% chance of La Nina for August to October. That's quite an aggressive forecast. I think physically that makes sense. But you can see, if we're looking for El Nino, that's about 1%. So the odds of El Nino this summer and fall are very, very low. There's a whole lot of different models. So trying to get the El Nino modeling being kind of late. There's a whole pile of different models forecasting ENSO. And so we have dynamical models, which are full physics models. The atmosphere ocean, we have statistical models, which are based on historical data. If you love acronyms, there's a whole pile of acronyms. I can probably tell you about 2/3 of them, but there's some I have no idea what those stand for. But most of them are calling for La Nina. Some are calling for neutral. You see, there's nothing above the threshold for August or October. If you go closer to home, this is the North American multi-model ensemble. So these are 7 models from the United States and Canada. And all of them by September, which is what's denoted by the black arrow, are calling for La Nina conditions. And again, these are all from March. A lot of these plots will be updated here in the next couple of days. So you can check on these various websites and get updated forecasts that coming up shortly. So why do we care? So why do we go back and have to quantify? Why do we care about El Nino and La Nina? We say it matters, but how much does it matter? And so this is basically going back to 1900 and looking at the number of storms, hurricanes, and major hurricanes by ENSO phase. So we have La Nina, we have neutral, and we have El Nino. And here we're going back to 1900. So especially the main storms, those numbers before the satellite era in the 60s are likely somewhat underestimated, but the ratios are probably held up reasonably well. And so here we're taking the 30 coldest more than 2 to 1. Makes sense because you can get marginal storms in not particularly conducive environments, but to get a major hurricane, you've got to have a pretty decent area of conducive conditions. So you see greater than 3 to 1 ratio for La Nina and El Nino. Then they said, well, they're going to put out the GIS app from back in the day, but it's plots. So here we're looking at major hurricane tracks. In La Nina versus El Nino, it's the same number of years for both. You can see, obviously, which would you rather be? Right? Obviously, El Nino has a lot fewer, and you see a lot fewer tracks in the Caribbean. El Nino really increases your shear down there. And you can see, there's still some landfalls along, especially from like Texas to Alabama, maybe up into the Panhandle. But if you look, a more Florida to Maine, you see a whole lot more tracks in La Nina than in El Nino. So if we look at the differences for Texas to Alabama, and we look at ENSO phase, we do see there is a relationship, but it's fairly weak, and some of that is due to the fact that, Gulf or Texas to Alabama hurricanes tend to form, off the coast of Africa, come all the way across. They sometimes come out of the Caribbean, but you can also homegrown storms, and those homegrown storms don't have much of a relationship with ENSO, because often they're more frontal in nature, at least the way they start forming. But if we look at Florida to Maine hurricanes, we do see more significant ratios, especially for major hurricanes, about 2.5 to 1. And that's because a lot of those storms are the ones that come off of Africa, come all the way across, and those conditions tend to be more conducive in La Nina years. La Nina years also, very broadly speaking, do have a little bit stronger subtropical ridging, so it tends to push the storms a little bit farther to the west. Unfortunately, a lot of those relationships are stronger in the winter than they are in the summer. Summer signals in the mid-latitudes tend to be fairly weak. So what I thought was interesting was, let's actually look at damage. And so here we're looking at is normalized damage. So obviously we know these storms in the past, if they were to make landfall today, would cost a lot more money due to changes in inflation, which is not an insignificant thing, as well as population and wealth. And so, for example, we talk about this 1926 Great Miami Hurricane, caused about $80 million in damage in 1926. That hurricane, if you do a normalization, is about $200 billion today. So if we look at these $10 billion storms and we look at the odds by ENSO phase, certainly obviously the odds get much higher, especially for Florida and the East Coast in La Nina. You might be wondering, what is that 3%? What year was that? So again, we have 30 years, so 3% is 1 year, but that 1 year was 2004. So again, it's important to realize that you want to look at more than just one index at a time when you're talking about hurricane seasons. The Atlantic's still hot. Now, if I had showed you this plot even like 3 weeks ago, looking at the 14-day average, it would have been even darker red. So that we have backed off a little bit, but it's still extremely warm in the Atlantic. Pretty much the entire Atlantic is very warm right now. Unfortunately, if we look at the correlation map that we normally see, so this is a correlation map of April sea surface temperatures with accumulated cyclone energy. And this is basically the optimal pattern for a busy hurricane season. If we step back and look at that, and then we look at that, it's not a correlation of 1, but that's pretty close. So that's, again, one of the big reasons why we're forecasting a well above normal hurricane season. If you look at the current sea surface temperatures in the tropical Atlantic, and you say, okay, we're going to warm at the slowest rate that we've warmed between now and the peak of the season, you're still talking water temperatures that are, say, like top 5 warm. So unfortunately, I think it's at least a little bit of kind of a dire task for 2024. Now, certainly you can get atmospheric patterns that can cause this to anomalously cool, but just given how warm it is, it's going to be hard to shake all that warmth between now and the peak of the season. These anomalies are highly elevated. 1 to 1.5 degrees Celsius warmer than normal in deep tropics, that's a big deal. That's a lot of warmth. And so what I wanted to do next is we'll talk a little bit about some of these climate model forecasts. So this is the forecast from the North American Multi-Model Ensemble, so the 7 models from the US and Canada. And again, this plot will be updated on the 8th of April, but I suspect it'll be fairly similar. So it's calling for a robust La Nina and a very warm Atlantic. And so what I want to highlight next is relationships that we see with basically what we see when we have a very warm Atlantic. So we can see the model projections are for a very warm North Atlantic relative to the southern tropical Atlantic. And that is typical of what's known as the Atlantic meridional modes, and you may have heard of this, but basically it is when the northern tropical Atlantic is extremely warm relative to the southern tropical Atlantic. When that occurs, you tend to get lower pressure in the northern tropical Atlantic, you get more cross-equatorial flow. With Coriolis, you tend to get winds out of the west at low levels, which helps to spin up storms in the eastern and central tropical Atlantic. it tends to also favor more, basically it helps bring moisture onto the African continent, helping to revitalize the African monsoon. You get enhanced precipitation across the main development region, again, likely causing more conducive conditions for hurricanes in 2024. And so we can do the same analysis we did with ENSO, but with the Atlantic Meridional mode. And if we look at these relationships, we again see stronger relationships for major hurricanes than we do for the number of storms. This AMM index goes back to 1948. So here we're looking at the 19 years where that index was the most positive in August through October. Those are our positive years. The years that are most negative in 19 are negative, and everything else was neutral. And again, if we look at the plots, you see one of the things that the AMM does is it really impacts storms in the eastern and central part of the basin. You get a lot more formations there. And you can see, right? If you look at the negative AMM, you look east of the islands, there's zero. No major hurricane tracks out there. And so when you have an AMM positive, you start to get a lot more tracks in the central and eastern Atlantic. And again, you see some landfalls for Texas to Alabama, negative AMM, and again, really highlighting more storm formations potentially, potentially some more storm up towards the east coast. If we look for Texas to Alabama, again, you do see an increase in the relationship with when the AMM is positive, but a little bit stronger for the for Florida up to Maine. We can do the similar analysis with the $10 billion storms, and we do see more when it's positive than when it's negative. But again, the relationship is a lot stronger for Florida up to Maine. But then what you can say is, okay, well, at this point, the odds are pretty good we're going to see a positive AMM. I'd say that odds are rather extremely high. Odds of La Nina are also pretty solid. So if we look at the 11 years where we had a positive AMM and La Nina, so combining basically the Atlantic and the Pacific, compared with the negative AMM and El Nino, you start to get really pronounced relationships, about 4-1 for major hurricanes, as well as major hurricane days. You just see a lot more storm activity in general. So, you know, we can't say for sure that's what's going to happen, but I would say the odds certainly favor the top plot. The odds of the bottom plot, if that happens, you know, I need to go back to school and try to figure out some other stuff to do, because that would be extremely surprising. All right, so again, if we quantify this again, we're talking about a 4-1 difference, especially for major hurricanes. Again, highlighting how the stronger the storm, the stronger the relationship, because again, you need a much larger area of conducive conditions for the storms. So what I want to do next is talk about some of the model projections. So the European Center model, these will actually be updated tomorrow, but their forecast in March was for a pretty cold tropical Pacific. This is kind of borderline La Nina to cool neutral. I think honestly, even if we didn't go all the way to La Nina, assuming the Atlantic remains extremely warm, it doesn't necessarily really matter in terms of activity. We likely just saw a very busy season. The Atlantic also very warm. And so the European Center model, in addition to making forecasting on a large scale, will actually track storms. And so they can count the number of hurricanes. And so this kind of distribution of storms in the Northern Hemisphere is very classic La Nina, where the Western North Pacific is down, the Eastern North Pacific is down a little bit, and the Atlantic is highly elevated. So right now the forecast goes out through September. And so from April through September, the model is forecasting a highly elevated amount of storms. So the forecast is for 8.7. You might be wondering, how are these 8.7 hurricanes? I've never seen 7/10 of a hurricane. I mean, you could argue some of these shear things are, half a hurricane. But the way that it happens is you have an ensemble. You have 51 members, and so each member would have a round number. So 9 hurricanes. But if you have 9 hurricanes, and you have 8 hurricanes, and you average it, you have 8.5. So that's how we get 8.7. And that's only through September. On average, October has 2. So you can say with that, probably about 11 hurricanes for the season. That's again basically what we're forecasting. So in line with what is being forecast by the European Center. And again, this forecast will be updated tomorrow. I know everyone wants to know, where are the storms going to go, right? That's the $1 million question. And so, last year, not in March, but more like April, and especially in May, the European Center and UK Met 2, we're highlighting enhanced precipitation. And I like to look at enhanced precipitation, especially in the deep tropics. This isn't a bad harbinger for tropical cyclones. And if we look in July through September, which again is as far as the model goes, you do see enhanced precipitation, but it's more in the western Atlantic, which is again a classic La Nina signal. And so obviously this is not perfect. If you look at the skill maps, there's not a ton of skill forecasting this far out, but highlighting kind of what you more would expect in La Nina. La Nina really enhancing your storm formations and enhancing activity in the Caribbean, because again, we saw last year it was a busy season, but not much in the Caribbean. The Caribbean had a lot of sinking air last year. If we switch to La Nina, the air should be going up more in the Caribbean, likely making that area more conducive. Obviously, Caribbean storms, what we really don't want, because obviously they either impact Caribbean, Central America, sometimes also get lifted up by troughs and start impacting the U.S. So how do we come up with these forecasts? Well, we use a variety of different techniques. And so this is kind of the throwback technique to what Dr. Gray was using in the early 1980s, and that's a statistical model. So the statistical model says, okay, we got to do the forecast April 1st. We only have data through March. So let's look through March and see what conditions during basically the winter or early spring correlate with hurricane activity, several months later. And so we use three predictors, two sea surface temperature predictors, one in the Atlantic, one in the Pacific. So the Atlantic predictor is getting basically your overall basin warmth. The Pacific predictor, where the water's in the Coral Sea all the way up to north, basically when those are warm, that tends to help support a transition over to La Nina. And we also look at upper level winds over the Atlantic. There's actually somewhat of persistence there, where those winds are anomalously out of the west. That tends to mean more reduced levels of upper level or anticyclonic wave breaking, which can cause increases in shear and have been in our existence. A lot of our forecast busts have been due to enhanced tropical upper tropospheric trough and shear associated with that we didn't expect. And so this model is certainly not perfect. You're never going to get correlations of one, and especially in April. But in general, the model does a reasonably good job. There are some forecast busts. Again, it's April, the hurricane season starts June 1st, doesn't really ramp up until August. Dr. Gray used to ring the physical bell every year on August the 20th, signaling the after part of the hurricane season. Certainly last year, we went through August 15th or so, and it was very, very quiet. We looked at August 19th, the tropical weather outlook had 5 areas on it, all 5 of them formed, got extremely busy, and that's why we issue these updated forecasts, because even though season starts June 1st, doesn't really ramp up until August. And again, so we can see the models that general has reasonably good levels of skill, going back to the late 1970s, basically the kind of the global coverage of satellites. So this model is extremely active. You're talking basically record models. And so the final forecast is actually below all of our model guidance from all of our numerical models that we use. But still, certainly a very, very active season. Overall, at this early lead time, I think we need to be a little bit careful in terms of going too much higher than what the forecast has. We also use statistical dynamical models, and these are models that Dr. Gray couldn't have had in the early 80s because we didn't have kind of models forecasting 3-6 months out. But now we can. And one of the nice things with these models is that they have basically hindcast periods, so they can say, okay, how good are these models based on past data? And since they're based on dynamical equations that govern the atmosphere and ocean, in that case, past performance should be, at least somewhat, a good predictor of future results. So we can look and see, how good are the models at forecasting, sea surface temperatures. So here we're looking at forecasts through the month of August. So we're looking at August forecasts of sea surface temperatures in the tropical Pacific. So basically assessing the state of ENSO. Also looking at temperatures in the tropical and subtropical Atlantic. So if you're looking for a busy season, you want warm in the Atlantic, cold in the Pacific. Opposite obviously generally leads to quieter seasons. So we do this for a few different models. This is we're going to use the European Center model as an example. So here's the plot I showed you before, but with the Pacific box and the Atlantic box drawn on to give you an idea of kind of what you would expect for values there. So you say, okay, very warm Atlantic, cold Pacific, likely leading to quite a high hurricane season. And the model shows reasonably good levels of skill. You get about 35 or about 40% of the variability, which isn't bad for early April. Again, there's still a lot that can change. As you would expect, if I were to show you a prediction from June or August, the skill improves because, again, we're closer to what we're trying to predict. The European Center model, this statistical dynamical model, ACE is about 230, which again is extremely elevated. If you were to actually take the ACE that the model was actually forecasting, it would actually come out with a level approximately similar to that as well. We have a whole pile of other models that we use. We use the UK Met Office model, the Japanese Meteorological Administration model, and a research model out of Italy. All three of these also calling for an extremely busy hurricane season. So if you go into our forecast on our website. There's a whole lot of discussion about why we came up with the numbers that we did. It's not just the forecast numbers. There's a lot of work that goes into this and a great team of people working on this. And so we also use analogs. And so, analogs are tricky. Obviously, there's no snowflakes, no 2 years are exactly alike. And so this year we actually looked way back in the historical record books to try to kind of get some better analogs. The question is, what do you want to use to pick your analogs? You can go back and you can try to, look for years with really warm Atlantic, but you want years that were transitioning over from El Nino to La Nina, and trying to kind of find all of that. There's not a ton that had all of that, especially in Atlantic as warm as it is now. So you kind of have to sacrifice something for each of these years, because obviously from a warm Atlantic perspective, the year I'm on is last year, but obviously that was a strong El Nino. So we went back and we found 5 years that I thought were reasonably good analogs. So the first one is all the way back in 1878. In 1877, it's certainly a very strong El Nino. There's a lot of evidence in addition to kind of marginal water temperature records back then that was a strong El Nino. So 1878, and it was a pretty busy hurricane season based on the data that we had back then. Obviously, like we missed some storms in 1878 without aircraft and obviously no satellites. Another year we selected was 1926. Obviously, an extremely busy hurricane season that year. And then we selected 3 years, 98, which was coming out of a very strong El Nino, 2010, which was a moderate El Nino, and then 2020, which didn't have El Nino, but the Atlantic was extremely warm that year, and it was kind of a marginal, warm neutral-ish event in 2019. So again, not a lot of perfect analogs, but these are the 5 years at this point that we thought matched up the best, and this is the composite of those 5 analog years. So a cold tropical Pacific and a relatively warm Atlantic. So here's the activity average in those 5 years. Certainly named storms in 1878 and 1926. Those numbers are way too low. I don't know what they are, but certainly we have more than 12 named storms in 1878 and 11 named storms in 1926. If you have names of 230, you've got to have more than 11 storms, I would guess. But overall, you can see a lot of storm activity in those years. Overall, if you were to kind of take in, especially those first 2 years, and add a few storms, like in some ACE, the numbers would match up pretty well with our final forecast. And again, there aren't any perfect years. Certainly, if others were to do analogs, I'm sure guessing they would come up with some other years, but these are the 5 years that we thought worked the best given the current large scale. Obviously, these forecasts are perfect, so what we try to do is we calculate the uncertainty associated with these forecasts. And obviously, this is April, so the uncertainty is fairly large. So we can calculate probabilities of exceedance. So basically, take the kind of observed climatology of ACE, in this case, and then we can basically fit that to a statistical model, and then basically estimate the uncertainty associated with these forecasts. Because obviously we know these forecasts aren't perfect. So using the historical errors of our statistical model, we can calculate a 70% confidence interval. So, we have all the way up to like the most active season on record, potentially, but also all the way down to a year pretty similar to what we saw last year in terms of ACE. We can do a similar analysis for all of our different parameters, and so these are our uncertainty ranges. And if you look at NOAA's forecasts, they're pretty similar in terms of their spreads. Usually it's about 2 to 3 hurricanes, maybe two major hurricanes. And again, these uncertainty ranges, if you say look at our June forecast, those uncertainty ranges will be a little bit smaller because we're more confident about the predictions as we get closer to the events that we're trying to predict. But just at this long lead time, there's just a lot of uncertainty. So when people say, how confident are you historically, it's about plus or minus 3 for hurricanes. This year, I'd say we're a little bit more confident, certainly than we were last year at this time, just given last year was kind of like these 2 big giant factors going at each other, whereas this year it's looking more like they're all going to be kind of pulling the same direction. As I mentioned before, we do forecast ACE west of 60. The reason we do that is because, again, that's where people live, and so when we do our forecast, we want to kind of highlight more where people are likely to be impacted. And we can't say, months in advance, the storm is going to make landfall in a specific spot, obviously. But we can try to highlight, okay, maybe the western half of the basin is going to be busier. So last year, we were pretty confident even in April that we're going to see a pretty healthy El Nino, and that confidence just grew over time, and obviously it was a strong El Nino. So we said, okay, as we got closer, we said, okay, we're likely to have a busy season, but probably not a ton of, basically a little bit less ACE west of 60, because you tend to have, the Caribbean tends to be less conducive, and also it tends to favor broadly a little bit more recurvature east of 60 west. And so again, these differences aren't huge. It's about 50% in El Nino, 60% in La Nina. But because we were pretty confident we're going to see La Nina, the percentage of ACE west of 60 is higher. Due to two factors: one, the Caribbean is likely to be a fair amount more conducive than last year, and also potentially a little bit more straight movie tracks, but that relationship is a bit messier. So we do probabilities of landfall, and the way that we do these are we calculate the historical odds based on historical data, and then we adjust them based on now ACE west of 60, because obviously all the landmasses we're forecasting for, except for a couple of the far eastern Leeward Islands and Cabo Verde, are west of 60 degrees west. So if we look at the probabilities this year, they are elevated, not a surprise, because we're forecasting a above normal hurricane season. And what we did a couple of years ago, with help from colleagues, is we calculated for every county along the coastline and parishes for Louisiana, the odds of storms making landfall, but not landfall. We wanted to look at storms within 50 miles of each county, as well as each state, each island in the Caribbean, each province in Canada that's hurricane prone, and as well as the coastal states of Mexico on the east coast. Because we want to try to get an idea of, you don't have to have a storm making landfall in your county or your state to have significant impacts. If something's within 50 miles, you're not having a good day. So we wanted to expand it a little bit. It helps kind of smooth out the statistics as well. So here we're looking at Plymouth County, because that's where I grew up. And there's not a ton of hurricanes that hit Plymouth County. But if you look back historically, there's been 10 from 1880 to 2020. And we did this analysis using this this really awesome post.noaa.gov hurricanes website, which has all this historical hurricane track data, because that way it's easily replicable if someone else wants to go in and do it. They should get the same answers as we did. Except when the Hurricane Center reanalyzes yours, sometimes that can change things a tiny bit. But overall, we calculate the historical odds of storms within 50 miles. And so on our website, we have it for every county, and as I mentioned, all these other regions. Here's an example of several states. We do have it for every state, but I didn't want to have a font of 8 point on this plot. So we're in Texas, right? So let's look. The probability of a hurricane in Texas, within 50 miles of Texas in any year, is about 35%, 36%. This year it's elevated at 54%. And again, all of this is on our website. So if you want to dive into more detail on all these interesting, at least what I think are interesting statistics. So we will update the forecast. We'll update it again on June the 11th. We'll update it again on the 9th of July, and the final update on the 6th of August. And again, people will say, well, the 6th of August, that's 2 months into the season, that's cheating. Well, they'll say that issuing a forecast for the Super Bowl at halftime. It's more like issuing a forecast for the Super Bowl after the opening drive of the game. There's a lot that can happen between early August. Usually only about 5% of your major hurricanes occur by the 6th of August in an average hurricane season. If you can't get enough of seasonal hurricane forecasts, I bet you check out seasonalhurricanepredictions.org. We've got about 30 different groups that have submitted or that submit seasonal forecasts each year. The number changes a little bit each year. Sometimes groups drop off, we get new groups. So all of these groups, we have private sector weather companies, government agencies, as well as universities. I will note that there are more hurricane forecasts from universities in landlocked states than in states that border an ocean. So, he used to ask Dr. Gray why forecast hurricanes in Colorado, and he said it's because the storm surge can't get you at 5,000 feet. So we have all these forecasts, and to give you an idea of what this website looks like, here's a visualization from last year. So on the y-axis, you have an orange dot, which is the average of all the different forecasts. The red dot is the observed value. So last year we had 7 hurricanes. And so these forecasts are color-coded. So purples are private sector weather companies, greens are universities, and blues are government agencies. So we have a whole pile of different forecasts. And one of the reasons why we wanted to get this website started, and we worked very closely with the Barcelona Supercomputing Center, who hosts the website and does great maintenance on it, is that we wanted to kind of highlight the uncertainty associated with the forecast. And so some years, the spread of the forecast isn't very much. Like this year, I'll show you in a second, the forecasts are pretty much all calling for a well above normal season. But last year there was a fair amount of spread, and that's because there was a lot of uncertainty as, what's going to win with this clash of the titans between the strong El Nino and the extremely warm Atlantic. So that's really one of the reasons why we want to get this website started. So we started in 2016. We're gathering statistics each year. We're probably starting to do some verifications once we get maybe 2 more years. We get about 10 years of statistics, so you can kind of see, if there are particular groups that are, doing much better than others. I mean, all in all, probably when you look at it, the statistics are going to be kind of modeled because there tends to be a lot of agreement in some years, but certainly other years, like last year, there can be a little more disagreement. So this is the forecast for 2024. This plot hopefully now includes my forecast as well, or our forecast at CSU. I just put in the numbers right before coming down. It usually updates every hour, so we'll see. If you go to the website, maybe it's there. I don't know for sure. But the forecasts so far are elevated. The red dot is 0 because we haven't had any forecast or haven't had any hurricanes yet. The average of these forecasts is 10. Obviously, putting the CSU forecast will help up the numbers a little bit, but still, still looking at a very elevated season. We'll see what transpires. There should be a few other groups submitting seasonal forecasts here in the next couple of weeks. There's also a couple of forecasts I know that have been submitted or that have been issued that we're working on getting right now. There's been some login issues that always can occasionally play things on when you're putting in seasonal forecasts. But certainly, whenever we do forecasts, I know we got a lot of forecasters here in the room. I know I've probably shown this slide probably pretty much every year in Dr. Gray before me. Arago's admonition, he was the head of the Paris Observatory in the middle of the 19th century. And he said, never no matter what may be the progress of science, honest scientific men or women have regard for their reputations, who have regard for their reputations venture to predict the weather. So with that, I'd like to thank you very much, and I will try to answer any questions. So thank you.